Welcome to PC Woods Kids Tech Talk. Today we're looking at the gaming DDR4 memory from Kingston, the HyperX Fury RGB. I've got a kit here of two 8GB modules for a total of 16 gigs, of course. This is gaming memory, okay, with RGB capabilities. Obviously, you want those cool color effects. The memory itself's got a nice black, heat shield on it with the HyperX there and Fury written on it, and it looks really cool. Like it. Now, whether you have Intel or AMD Ryzen ready to go, this one has a speed of 3733 megahertz, CL19 timings. It comes in different flavors and sizes if you want. You can see right there. And, basically I'll be using the XMP profile number 1 that it comes with, which is the CL19 232323 at 1.35 volts. That's what I'm going to select and use. I might overclock this a teeny bit just to show you guys, but it all depends, of course, on the CPU that you're using and the hardware, how much you can overclock, so results will vary. But I'm concentrating on using this at the default XMP profile setting, and you can see the memory is nice and slim with the cool RGB lighting at the top. And of course, you can change that lighting to whatever color you want, change the effects of that. We're going to look at that towards the end of the video. This is the system that I'll install this beautiful RAM inside. As you can see, high quality components. Obviously, we don't want to hold this back. We want everything to shine and run at its fullest. In the BIOS, I double check the presets, the predefined memory out of the factory. You can see right there what it's detecting on this motherboard. Your motherboard screen might look differently than this, but it should show the same results when it comes to looking at the memory specs. I'm going to be loading the XMP 2.0 profile right there that you can see for the DDR4 3733, like I mentioned a second ago. And if I select that, it's going to populate all of the required memory, timings, voltages, and so forth. I already have my CPU overclocked to 4.2 gigahertz, as you can see right there. And I'm going to just leave the timings and everything as is for now. Overclocking this a little bit further, yes, it can be done, but right now this is what it looks like in Windows 10 and CPU Z or Z. As you can see there, 4.2 gigahertz on the Ryzen 5 3600 CPU, running on this beautiful ASRock X570 Steel Legend board, which I made a separate review of this, by the way. And also you can see the default memory timings that I'm running, this 3733 megahertz at the CL19 timings, the CL19 2323. Okay, now if I were to overclock this, I'd go back into the BIOS, back into the UEFI settings, and change the CL, the CAS latency to 18, and then I'd increase the frequency to 1900 megahertz or 3800 megahertz total there, so that way I can get a little bit of a boost. But going back to the default clocks, you can see the scores that I got when I ran the bench CPU button there. It gave me the single thread and the multi-thread scores. On the single thread, I got 522, and it beat all of those other processors, which is great. I mean, it beat the 3700X. So you can see good quality machine, board, and memory make a huge difference. On the multi-threaded score, because this is a 12-thread CPU, you can see how well this memory performed to really give this system and help it boost according to other types of benchmarks that were submitted as well. So very impressed so far on these results. And yes, if you overclock this to 3800 megahertz, the DDR4 memory, you do get a slight little boost as well, okay, obviously. But going back to default clocks, AIDA64 is showing me here on the memory benchmark, the read, write, and copy and latency. Those are the top scores that I'm looking at there, and I'm comparing that here to other Intel Core i7 machines, and you can see how it does. It does very well, actually, considering. And, if I compare the write benchmarks, you can see there as well how well it does. And the copy benchmark as well shows very good results for this machine compared to other Intel Core i7 6-core CPUs, because really that's what we're comparing it, a 6-core to 6-core, even though this might have 12 threads and some of those might just be 6 cores and not hyper-threaded, but these are all hyper-threaded, which is great when you compare things. The latency here, 70 nanoseconds, is very respectable for an AMD machine. Okay, remember, AMD versus Intel, totally different scores there, of course, but really we're comparing here against other machines that are in the same ballpark And I'm very happy to show these results because that's really what you want to see. You want to see decent results. It's actually doing faster than an Intel Core i7 8700K, which is pretty good. Now, if I overclock it to 3800 megahertz again, yes, you get a slight boost. The latency actually gets faster at 68.2 nanoseconds, which is great. And also, you can see here on the memory read, when I overclocked it, it actually beat the Intel Core i7 4930K, which it hadn't before at the default clocks. In Passmark version 9, 6192 is the overall system, the entire system. That's how it's rated it. But I'm really looking at the memory mark, okay, of 2946 and all of those other subscores. So the memory read uncached of 18325, the memory write of 12083, and the latency of 31. Those are the three that I'm looking at. So the first one here on 18.3 MB per second, you can see right there how it's scored and compared to these other types of memory, which is very nice. Okay, and also on the right, you can see 12.083 meg per second, and also how it compares to these other memory modules. Last but not least, we've got the latency, which actually proved to be very fast. So 31 nanoseconds was right up there, the fastest being 29 nanoseconds. So pretty darn good there. And again, if I overclock this to 3800 megahertz, it brought this boost up. And when I meant it boost, the latency actually went to 30 now nanoseconds. So it was actually increased in performance, which is great. I like to see that. Now, overall, 4.5 stars out of 5 is what the Passmark benchmarks gave, and that's because of the CPU, the memory, the disk, the NVMe SSD, and the motherboard. All of those components together really gave it a good score. Now, you can see here the max mem 33.12 GB per second on the read. Okay, that's what we're focusing on, the score here, the read score. If you were to take that and compare it to other systems, so there's my score of 33.12. It actually scored the same as an Intel Core i9 9900K machine with some other G-Skill memory, as you can see right there. So very good results. Very happy, considering how much this machine costs compared to an Intel 9900K. So very nice. The W prime calculations, great way to really see the operations per second and all of that. The CPU is obviously put to the test here, but the memory is helping out. And the RGB feature it's there. It's there for you to use, whether you use the built-in features of your motherboard, the Asus Aura, the ASRock, the RGB built-in with your Gigabyte or MSI. It will use those built-in applications, or you can download their own Ingenuity HyperX app, which is in beta right now, and control the features like that. I like the wave that goes up and down in one color, but you can have it obviously alternating. You can have it in other colors. You can have it solid, static. You can have it blinking. I mean, you name it. There's all kinds of different effects. You can have it synchronized, obviously, with other components in your machine, which is nice as well. There's the meteor, there's the side-to-side wave thing, So, I mean, there's all kinds of effects, right? It just depends. And you can control the speed, by the way. It doesn't have to be fast like this. I'm just going through it at a faster pace for you guys. But you can slow down how fast the colors appear or scroll by or blink or fade or breathe or whatever, right? You can control that. Now, for those of you thinking, well, what about gaming? Because that's what you're going to use this for. Yeah, sure, it looks great inside the machine, but does it, give you good results? Of course it does. I'm running all my games on ultra high display settings or high display settings depending on your resolution. This machine, I've reviewed the graphics card, the motherboard, the CPU, all of these separately, so you can watch individually the reviews for each of these components. I'll add the links at the end of the video so you can see how well this graphics card and the CPU actually works. Obviously the memory has a part to play here, but in these benchmarks the graphics card is really doing the heavy loading, obviously, and the heavy lifting, I should say, on all of the rendering. But you want to make sure that this is giving you good results, and of course it is. Look at those results. Frames per second are like way up there, and I'm really impressed. I mean, nothing was held back. There's no bottlenecks. Everything is being run at high or ultra high, no matter what game. This is being rated obviously as an extremely high setting whenever you're playing these types of games, this machine looks great. I mean, the memory, the RGB settings are awesome. It's stable. Yes, you can overclock it slightly, which is what I did, but not too much because of the CPU that I use doesn't allow it to be overclocked too much. That depends on your CPU and system, of course, how much you can overclock, but the performance at the end of the day for gaming is excellent. Here are the different types of reviews that I did that are from this exact machine. So if you're interested in any of those, click on these right now. Comment below. Let me know what you think. If you haven't subscribed, click on the subscribe button, please. And again, thank you for watching.